We're going to talk a little bit of hyperbolas, just a little quick intro to it. I'm not going to read all that for you. You can pause it and read it if you want to. And there's some really good terms and some nice pictures. We're going to talk about what all that means, what I'm looking for here in a second. So I've got a problem that looks like this. First thing that comes to mind is how similar this looks to an ellipse problem, except for the fact that that is a minus sign. And usually with our ellipse problems, we always had the x squared term coming first, but in hyperbolas, the y can come first, and that tells us something. So similarly to an ellipse, my center for this one would be at 0, 0. You look at the x term first, so if this had said like x minus 2 squared, like we would have put it 2 and then a 0. But I looked here, 0, and then there, 0. So let's come over here, let's graph it. 0, 0. And the next thing I do is similar to ellipses. So I'm going to count up and down 3 and left and right 4. So up and down 3 and left and right 4. And instead of drawing an ellipse, I'm going to draw me a little box here, okay? So I've got me a box. Little rectangle, and that's going to help me out here in just 1 second. Okay, next piece of information that I'm looking at is it going to open up or down or left and right? So when the y comes first, when you're subtracting the x value, that means that it's going to be up and down. The other way around, if the x had come first, then it would be going left and right. So I know that my graph is going to look something like this. So I'm going to draw that hyperbola here in a second after I draw my asymptotes. So my asymptotes are going to go from this corner through the center, this corner through the center, and vice versa on both sides. So like, this is not perfect by any means. But it's going to look something like, so those are my asymptotes. And we said it's going to open up and down because the y came first. So I'll have a hyperbola that looks something like that. And my vertices are just kind of this bottom point, just like as if it were a parabola. That's a vertex right there. So that would be at 0, 3. And 0, -3. And I'm looking for the asymptote slope right now. We'll get a little bit more complicated here in a second. But the asymptote slope would be your rise over run for this line. That's why I put a big dot right there. That's why we drew the rectangle. So my rise over run would be rise 1, 2, 3, and over 1, 2, 3, 4. Likewise over here, it's negative slope. You rose 1, 2, 3, and ran 1, 2, 3, 4. So my asymptote slopes, I should say, or asymptotes slopes, I don't know. The S would have an apostrophe after it, maybe, I don't know. M equals plus or minus 3/4. And when I'm finding the foci for a hyperbola, I'm going to say plus this time instead of the minus we were doing with the ellipse. I always just think about it as it's the opposite of whatever's up here. That's what you'll do for the foci. So I'll say c squared equals 16 plus 9. C squared equals 25. That means that c equals plus or minus 5. And similarly to the ellipse, we're going to go here and start at the center, and we're just going to count towards the graph. Okay, so I'm going to count up 1, 2, 3, 4, 5, and then down 1, 2, 3, 4, 5 right there. So those would be my foci at 0, 5, and 0, -5. Let's look at another one. So I want you to find this one. And my center, so I'm going to look at the x first. So that would be at 2, -3. So So I'm gonna come over here to 2, -3, plot my center. And I'm gonna count left and right 5, up and down 2. Left and right 5, up and down 2. So left and right 5, and up and down 2. And then that'll be where my box is. Like that. And my asymptotes would look something like this. And since the X comes first, that tells me that it's opening left and right. So right here, we could say left and right. And my graph would look something like this. Okay. And my vertices would be right there and right there. So that would be at 7, -3, and -3, -3. Okay. And the asymptote slope would be what? Up to and over 5, and then down to and over 5. So that would be m equals plus or minus 2 over 5. And if I want to find my foci, I'm going to say c squared equals 25 plus 4. C squared equals 29. That means c equals plus or minus the square root of 29. Gross. That is about equal to 5.38. Okay, so we're gonna go just a little bit further than 5 on the graph over here. So I'm gonna come up here and I'm gonna start at the center and I'm gonna count towards the graph. So I'm gonna go 5.38 right there. So since I went left 5 for that point, I knew it was just a little bit further than that. And then I went 5, and then I know it's just a little bit further than that. So my foci will be at -3.38, -3, and 7.38, -3. Sometimes you see that written as plus or minus square root of 29, so they'll use the center and they'll say like 2 minus a square root of 29 to go that way, and then 2 plus a square root of 29 instead of 7.38, so just be aware of that. Okay, let's look at this one. And we're gonna add one more step. We're gonna add the asymptote equation here. So hopefully by now we know if it opens left or right, and we can slide that down a little bit. The center of this, I'm gonna look at the x value first. So that would be at 2, 0. So I'm gonna come over here and plot my center at 2, 0. And I'm going to go up and down 6 and left and right 8 for my box. So up and down 6 and left and right 8 for my box. Okay. And I can draw my asymptotes to look something like that. I gotta go through that point right there. That point, that point, that point, and that point. Okay. And when I look over here, I see that the y term came first, so it's going to open up and down. So something like this. Okay. And my vertices would be be at 2, 6, and 2, negative 6. Okay. Let's skip down to the foci, and then we'll save the asymptote equation for last. So the foci would be c squared equals 64 plus 36. C squared is 100. That means c is plus or minus 10. So I'm going to go over here to my center and count towards the graph 10. Be right there. And then 10 that way. So my foci would be at 2, 10 and 2, negative 10. Okay, those are my foci. And let's look at the asymptotes. So my asymptote slope, that's real nice and easy. You can just count looking like this. Up 6 over 8. So 6 over 8, that's going to reduce to 3 over 4. And likewise, it'll be negative 3/4 as well. So I'm going to write it like this. M equals 3/4, and then M equals negative 3/4, because we're going to have two of them. And now I need the equations of those lines. So I need the equation of this line and the equation of that line. Let's look at the equation of this line first. When you write the equation of a line, you need two things. You need a slope and a y-intercept. So I'm going to write it kind of up here. You know, we could use y equals mx plus b to find those two things. We have our slope. Let's use the 3/4 one to start with. And we'll use that and a point to figure out what our y-intercept is. Well, we got a couple points that we know, I guess 3 points that we know. I'm going to use this 2, 0 point. I guess I could have used that point or that point. Any of those would work. I'm going to use the 2, 0. That would just seems too easy not to. So that'd be 0 equals, that's 6 over 4. That's 3 over 2. Plus b, so b equals, subtract that over, negative 3 over 2. Okay, so when my slope is 3/4, that means that my y-intercept is negative 3 over 2. So let's write y equals 3/4 x minus 3 over 2. That's one of them. And then we'll write the other one. I'm going to slide down right here. So I've got y equals mx plus b. And I'm going to use the negative slope this time, negative 3/4. And I can use the same point. You know, I'm looking at this line, so I can still use the 2, 0. So in this case, that would be negative 6 over 4, which is negative 3 over 2. Add 3 over 2, so you get positive 3 over 2. So when my slope is negative 3 over 4x, it's plus 3 over 2. Now you may be trying to find some sort of shortcut and say, oh hey, are those always opposite? No, it just so happened to be that way because this was on the x-axis. When you shift that around, it's going to change everything on that. Okay, so that's how you find the equation of an asymptote. And lastly, we're going to write one of these hyperbolas that is in general form. We're going to rewrite it in standard form. So same kind of deal as the ellipse, except I'm noticing that there's a subtraction sign in front of one of these. So we'll see what happens. I've got 4x squared minus 80x minus 9y squared minus 126y equals 365. And I can factor a 4 out of this one, so I got x squared minus 20x, and we're going to complete the square, so I'm going to leave a little space. The one thing that's different for the hyperbola compared to the ellipse is that I can factor out a negative right here, and I want to factor out a negative so that my final product is something minus something. Okay, like over here, you know, when we graph, I got a minus sign right here. I'm going to be able to factor out a negative number. So in this case, I'm going to factor out negative 9 y squared, and oh gosh, I get a 9 out of 126. I think it's 14. So I made that a positive 14. That's because I factored out a negative 9 from the y square, and then a negative 9 from that, so that made that positive. If I were to distribute that back, I would end up with what I had up top, equals 365. Okay, let's complete the square. So half of that's negative 10. Negative 10 squared is plus 100. I didn't just add 100 to this side, I added 400. And half of 14 is 7. 7 squared is 49. I didn't just add a 49 right here. I technically added whatever that is, negative 441. Negative 441. Okay. So over here, I've got 4. Two numbers that add together to give me negative 20 and multiply together to give me 100. Negative 10, minus 9. Two numbers that add together to give me 14, multiply together to give me 49. 7 squared equals 324. And we gotta make this stuff say equal 1 over here. So let's divide by 324 everywhere. And that'll leave us with x minus 10 squared over 81 minus y plus 7 squared over 36, and that is equal to 1. So my center is at 10, negative 7, and we can go from there.